probably think between these two problems that the one with the diagonal line is going to be harder. But on Draw the Missing Third View problems, diagonal lines are actually your best friend. And I'm joined by my best friend, your TA Indy right here. So having a diagonal line as your best friend, we don't judge. So the first step for every third view problem is going to be to draw the miter line and to draw yourself a bounding box that gives you boundaries. Is exactly what it sounds like, so that you know exactly where to place your new drawing. And your third view is going to fit entirely within this bounding box. Draw the bounding box very faintly because some of it may end up getting erased. Now, the reason that diagonal lines are so valuable is that an angled surface appears like a diagonal line on one view, but it appears as a surface or a face on the other two views. So for this red diagonal line that I've drawn here on the front view, we look on the top view for a line in that same place, that same length, and you get this six-sided shape. And what's great is that that exact same six-sided shape is going to also be visible on the right side view. It won't have the exact same measurements or dimensions. It could be squished or stretched because you're looking at it from a different perspective. But the general shape, the same number of points, all each connected to each other, that will be the same on both the top and the right side views. So I've numbered these points 1 through 6 on the top view, and you can see the points 1 and 6, 2 and 3, and 4 and 5 sort of coincide on the front view because certain points are behind the other ones. So on the front view, they appear as if they're in the same location. But on the right side view, all 6 points will be distinct, so you'll actually be able to reconstruct that same shape. And the easiest way to draw this shape is using the miter line to place all 6 points over on the right side view. From the front view, all 6 points will be directly straight to the right, exactly horizontal from their location on front. And on the top view, all the points will also line up across the miter line. So once you've lined up all 6 dots, 1 through 6, you just connect the dots and you get the exact same shape as on the top view. Now it's rotated 90 degrees because now you're looking at it from the side instead of the top, and it's squished, it's not nearly as long. And from the front view, you can see that that's because you're looking at it from a much more narrow angle on the right-hand side. Since the diagonal line is sitting kind of flat, it's much longer on the top view and much shorter on the right view. Now that's a lot of progress from just one diagonal line. This is why diagonal lines are your best friend. So we'll do this one more time with the other diagonal line that we have that I've highlighted in blue. Now from the top view, it's not immediately obvious whether points 4 and 5 are actually a part of both shapes or whether there's a vertical gap right there that maybe this shape that we're about to draw now is actually sitting a little bit lower than points 4 and 5. But looking at the front view, you can see that these two diagonal lines actually cross right at lines 4 and 5. And that lets me know that there's not a vertical height difference between those two, and that points 4 and 5 are therefore also a part of this shape that I'm drawing now. But that doesn't work for point 3. On the front hand view, you can see that point 3 is actually sitting much higher than the diagonal surface that I'm trying to draw right now. So that's why I added an extra point, which I've called point 10. So this new six-sided shape is going to be points 4, 5, 9, 8, 7, 10, to use the best numbering scheme ever. And to draw the shape on the right side view, again, all 6 points are just going to trace from the front view to the right side view directly to the right. And how far to the right they're going to go, you're going to get from the top side view by tracing across the miter line. And once I've found all 6 points, connect the 6 dots and darken them in, and we've got a new visible surface. And that's a ton of progress from just one diagonal line. For real, no judgment. It's perfectly fine to have a diagonal line as your best friend. So the bottom of this drawing is looking kind of empty, and it seems like we should just be able to trace that outline to make a shape, but we need to double check the front and top views to make sure that actually makes sense. So if that shape is a vertical surface over on the right-hand side, it should match up against a line on the right-hand side of both the front and top views. And it does make sense that those two orange lines would be where this new face is. And to think of this another way, imagine if that face weren't there, if there were some kind of hole down on the bottom. That would need to be visible somewhere on the front or top side view, and we don't see any features from the front or top side that make it look like there's any kind of hole down there. So it has to be blocked in as a solid vertical surface. So it seems like we could be done, but you got to double check the front and top views to make sure that you've actually drawn every feature, because there could be something hidden that we haven't drawn yet. And there's a hole. So this hole that's visible on the front view goes all the way through, as you can see on the top view. So it's going to go all the way through the right-hand side view as well. As I trace the lines for the very top and very bottom of the hole across to the right, I discovered that it looks like actually my lines 4 and 5 might have been drawn a little bit too low. I kind of guessed that they were right at the point on my grid line, just because practice problems, they usually do coincide with the grid lines. But now when I line up this hole, it actually seems like the top of the hole is actually on the grid line, and point 4 and 5 actually should be a little bit higher. So I'm going to redraw that line first, and then I'll draw my 2 dotted lines for the circular hole next. Now, one thing that I am not going to draw on this right-hand side is a center line. Visible lines have priority over center lines. If a visible line and a center line should both be drawn in the same place, you draw the visible line, not the center. Now, in this case, the visible line only goes part way. It only partially covers the center line. And even on the given topside view, you can see that part of the center line is drawn, the part that's not covered by the top view. So stylistically, I don't like doing that. So on the right side view, I am not going to draw a partial center line through the center of that cylinder. I think it's more confusing to put that line there than to leave it off. And ultimately, the purpose of an engineering drawing is to convey all the information needed and to not include anything that might be confusing. So I think this drawing is perfectly clear using the hidden lines to denote the top and bottom of the circle, and that adding a partial center line might actually make it a little bit more confusing than just not including it at all. I get that that's frustrating for a student. Sometimes you want hard and fast rules. Do this, don't do that. But when it comes to engineering graphics, a lot of rules are kind of meant to be broken on a case-by-case basis as needed in order to improve the clarity of the drawing. So over time, you'll get a little bit more experienced at just how to make your best judgment. If I were grading this assignment, I would give full credit if you included the center line or not. I think both of them are perfectly reasonable choices in this case. All right, 2-for-1 special on engineering drawings today. We got one more to go. And it's the drawing that actually looked like it might have been easier at the beginning. But really, these flat, vertical, and horizontal drawings are sometimes actually a lot harder. When you have a vertical or horizontal surface, you can only see the shape on one side. The other 2 views, it's just a line. And so missing third view problems with only vertical and horizontal faces a lot of times have to draw a bunch of individual lines as opposed to a smaller number of shapes. So to show you what I mean, the front side view is made up of 4 rectangles. Each of these rectangles is going to correspond to a vertical line on the right side view that's the same height as the rectangle, and a horizontal line on the top view that's the same length as the rectangle. And that vertical line on the right view and horizontal line on the top view will be at the same location across the miter line from each other. So in order to draw on the top view, we're going to pick a rectangle in the front view, find its corresponding height on the right side view, trace that line up and over across the miter line, and then draw it on the top view directly above the rectangle on the front view at the same miter line location as the right side view. Maybe just watch as I draw it instead of listening to this explanation. Right, the second rectangle corresponds to this small vertical line right there. And we can trace up and across the miter line and get this length over on the top view that's the same length as the rectangle on the front view. So numbering points was really helpful when drawing diagonal lines on the last drawing because you were drawing entire shapes and connecting the dots. I'm going to number the points on each of these rectangular faces on this drawing, but in practice, I probably would not actually do these myself. It may help you as you're first learning this technique to see, again, which points are on which views behind which other points. But in practice, I would probably not number the points on this type of drawing. It worked great on the last one with diagonal surfaces drawing the whole faces. This time, not so much. So we've got 2 top rectangles remaining, one small on the left and one big long one kind of on the right. But when you look over to the right side view, there's actually 2 vertical lines that are both the same height because both of these rectangles are the same height. And so is the question, which one is which? So the clue has to go with visible versus hidden lines. So looking at the right side view, you can see that both vertical lines are visible, which means the one on the right has to be in front of the one on the left. Or oppositely, when looking at this right side view, that left vertical line has to be behind the front one. And so behind on the right side view is left on the front view, which means that this small left rectangle on the front view is protruding further out on the front view. It's sticking more towards the front. So on the right view, it's more towards the left. So I can now draw two more lines on the top view representing these two rectangles based on which one had to be behind the other one. So we'll do this same process again, but on the right side view where I've outlined a blue, orange, and red shape. We already decided that that blue shape corresponds to the left small rectangle on the front view, so we can find its location on top by tracing straight upwards and add that vertical line there. This orange view is actually going to be all the way on the right-hand side, which means it's all the way to the right of the front view, and so it traces up to the right side of the top view as well. And then red is all the way down at the bottom, and so we can see on the front view, the first point from the right side that's at the bottom, trace straight upwards. And since this red shape goes all the way across the right view, it will go all the way across the top view. But a little bit of extra brain power is required on this one because since it's on the bottom, when looking from the top, part of it is going to be hidden, but not the whole thing. So the taller part of this shape would be visible because there's nothing on top of it, but that shorter right-hand side has the orange shape on top of it. And so we draw that section as a hidden line. So one thing that we haven't been able to account for yet are any faces visible on the top view that would just show up as lines on both front and right. And it seems like looking at the top view that the two candidates for this are going to be the whole top section and then the bottom right section. So the top section clearly does look like it corresponds to the top of the right view and the top of the front view. So you can darken in that left and top edges in order to close in that shape on the top view. That big shape in the middle that I've highlighted in yellow, you can see it does seem to correspond to these two lines on the front and right side views. So that seems to make sense. This is kind of double checking your answer. So last minute double check to make sure I didn't miss any features. Of course I did miss one. There's a hole. You can see from the dashed lines and the center line. So I use the miter line to find out where the center of this hole should be. The distance between the two dashed lines marks the diameter, and I'll draw my circle just by marking little dots on the four quadrants, draw the circular shape, add a center line, good to go. And last thing, what about this bottom right section of the top view? Well, looking at the front view, you can see that there actually is a hole down there that cuts all the way through the part. And over on the right-hand view, remember this circled section here was pushed back. Right, it sort of corresponded to where points 5 and 7 are. So that means this section actually is missing and does not need to be blackened in. And now that we go through and start erasing everything that you don't need, we'll just erase that part of the bounding box. Because remember, the bounding box is just a guide. You draw very faintly to erase it because it might not be part of the final drawing. And this section of it is not going to be part. And you made it to the end of the video. You're awesome. If you want to increase your confidence even more, hit the thumbs up for this video to show that it helped you out a little bit, and then watch this next video for some additional missing third view practice problems. You're probably getting pretty good at these already, but a little bit of extra help may help boost your confidence a little bit more and reinforce the skills that you've already developed so far.